Ladies and gentlemen, please welcome Serge Lucio.
Hello, everybody, and thank you for joining us. I was a bit worried, candidly. You know, it's pretty strange to talk about blockchain in the mainframe theater, if you think about it, right? In many ways, blockchain really is about peer-to-peer, right? It's about a distributed ledger, and in many ways, the mainframe has been, the central system which has the unique, the unique set of data that your enterprise is managing. So in many ways, I'm sure many of you are kind of wondering, why are we talking about blockchain in the mainframe theater? So I'm not going to spoil the beans. We'll get to that. But let me start with kind of a pretty broad statement and bold statement around blockchain and its importance in establishing digital trust. We've been speaking pretty much all day about digital trust and the need in this digital economy for organizations to be able to trust their systems, to trust the data, to trust the people. And in many ways, the blockchain is poised to provide a solution to a number of problems that organizations are facing with. Now, I think for many of us, we think of blockchain as kind of this, this technology that's on the side. It's in the fintech industry and it's a bubble, but it's real, right? It's not something that we think is in the future. It is happening now. If you look at the amount of money invested by venture capitalists to date, about $1.5 billion has been invested in ventures. When you look at the growth in terms of spend from enterprise customers in blockchain technology, it's growing at about 60%. And McKinsey is estimating that just looking at the financial and insurance industry, the potential for savings in the next 5 years are around $100 billion. And just looking through the press, looking at IBM as one of our partners, today there are hundreds of implementations of blockchain which are kind of in this proof of concept, moving into production mode. And it is real. It is happening now. And I invite you all to really start to experiment if you're not experimenting yet. So one of the misconceptions is that people equate Bitcoin to blockchain, or people tend to confuse Bitcoin and blockchain, and they are very different. Blockchain is the underlying technology that powers Bitcoin. But blockchain has a number of other attributes which apply equally to a number of industries and not just to exchange of currency. There are in fact two broad types of blockchains. The first one is what we know well with Bitcoin, and that's public blockchains. The Bitcoin is probably the most famous example of blockchain implementations. There are many other commercial ones. Ethereum is probably another key implementation in the open source space. And that represents a certain type of exchange of value that's very peer-to-peer, that doesn't require anybody that participates in that network to be permissioned. So anybody can join, anybody can exchange value. It's basically a free play. On the other end, we have what we call permission blockchain. And permission blockchains operate very differently. The members in the network are carefully selected. Members in the network need to approve any new member to join the network. And so in these permissioned blockchains, we see a lot of use cases which are not necessarily related to disrupting a central authority, but we see a lot of use cases which are really around providing transparency, around automating the long tail of business processes. And if you look at the different attributes in a blockchain network, all of them have a shared ledger. So a shared ledger is just an historical record of a set of transactions, and all the members have their own copy of that ledger. All have a notion of consensus, which is the mechanism by which the different copies of a ledger actually replicate and make sure that if one of a ledger gets attacked, that the system maintains consistency. Now, where permissioned ledgers really start to differ is really on this notion of privacy. Not everybody has access to everything, and really around this notion of smart contracts. A lot more focus when we look at implementations in permission ledgers, such as HyperLedger, around basically smart contracts which are automating a lot of these transactions and defining the rules for transactions to clear. So if you step back from the technology, and just if I try to boil down the technology, at the end of the day, it is a distributed database, right? All the ledgers are being replicated, so you have a notion of a distributed database. You have a transactional system, which is ensured by smart contracts. And the smart contracts also provide a mechanism for business workflow automation, right? So in many ways, a blockchain is just a new transactional system. So why is there so much hype around that? The hype is really related to kind of where you can apply that. Because of the unique properties of a blockchain, you can remove central authorities. You can completely disintermediate a lot of decentral entities which are controlling data. So in theory, you could create an Uber that's completely peer-to-peer using a blockchain network that puts you in connection with drivers, right? We would need to have a Facebook as a central entity that manages the conversation between you and your friends. You should be able to use a blockchain network to do that. And so ultimately, the real power of the blockchain is really around this disintermediation of a central authority. Now, the reality though is that if you look at most of the use cases that we've seen implemented in this first phase of adoption of blockchain, they tend to be much more mundane. They tend to be about providing visibility of data across different entities. They are about digitizing processes and the long tail of processes. So let me start with kind of a very popular example, Walmart. So Walmart is trying to really automate one of the tedious processes that they have today around food safety. And so the way they kind of approached that was first to try to get basically their entire supply chain from the producers to the packing industries to the shippers to actually provide a record on the ledger as to how this produce basically goes from farm to store. Now that historical trace is actually using what we call the immutability properties of a ledger. The fact that it's an app-and-only record, and because the ledger is shared among all the entities, at any point in time, everybody in the network knows exactly where that produce is and where that produce came from. And so literally, Walmart was now able to trace a product which had an issue, health-related issue, in the matter of seconds, while in the past it was taking them about a week. Now, this is great, right? But by itself, that use case is just automating a workflow process, right? They could have implemented that with any kind of other technology. Where the power starts to come in is when Walmart starts to invite Kroger's and all their competitors to join that network. And suddenly you have this ecosystem where you have producers on one side, the retailers on the other side, all exchanging the same data. And as you can imagine, you start to get into very interesting challenges, like who has visibility on what data, right? If I'm Walmart, do I really want Kroger's to know where I'm buying produce from? How long it takes for that produce to be shipped to my stores? But really the value in that example ultimately is really when you start to have competitors which are members of the same network. And so we're going to go through kind of a transition from very tactical implementations of blockchain networks, and there are many in the supply chain space, there are many around providing visibility of what in the past was heavily controlled. So for instance, a registry of deeds. Many countries, especially in Latin America and Africa, where historically there was no deeds, are experimenting with blockchain as a core technology to have that historical trace of who has owned that piece of land. So we're going to go through that kind of transformation. Now, to go back to the first question I asked initially, why the mainframe, right? What is the role of the mainframe in that transformation? And no, I'm not going to be speaking about reliability, availability, and security, because it has nothing to do with that. Yes, maybe a little bit, but fundamentally, the value of the mainframe relies on its architecture. One of the key objections, especially in public blockchains, is really around the intrinsic performance of a blockchain. There is the consensus mechanism that's used for Bitcoin basically as a physical limit of 7 transactions per second. Just think about it, 7 transactions per second. You cannot really run any kind of real system on 7 transactions per second. In a permissioned world, those rules basically are changed. The way consensus is being built on the blockchain is very different. And as a result of that, you can achieve much higher performance in terms of transactions per second. The next hurdle is no longer consensus, but really the crypto, because each block that gets added to the ledger is cryptographically linked to everything which has happened historically. And really where the mainframe shines is one, it's a transactional performance system, and 2, it has a very powerful crypto engine. Now, these are the 2 key attributes that ultimately really make the mainframe the workhorse for blockchain. Now, you add on top of that, secure containers, which IBM has introduced as a way to have this enclosure that is totally, which is a total fortress. You really start to see how the mainframe has a key role to play around blockchain. So let's get into kind of a meat of a discussion, which is we have a number of customers we're working with in pilots. And when we start to talk to these customers about how do you go from a pilot to production, these are kind of the 3 key challenges that we see again and again and again. So the first one is data security. I'm going to production, and I now need to really understand what kind of data is in this ledger. Do I have regulated data? Do I need to protect some of this sensitive data? Again, remember, we're in this environment where everybody has a copy of a ledger. And so data security becomes a very key concern. The second one is membership and governance. These customers are creating these networks where they are going to invite their suppliers, where they are going to invite other members, where they want to share information. What are the mechanisms by which a new member gets accepted in the network? I'll give you an example of HSBC and Bank of America. Both of these companies are partnering around letter of credit. Letter of credits historically have been very paper intensive. And if you're trying to get products manufacturers in China, chances are you're going to call Bank of America as your banker to have them issue a letter of credit to the bank of your supplier in China. And that whole process is extremely paper-based today, which really limits the amount of cash that these companies will typically work with in terms of letter of credit. And the other issue is that you have money which gets locked for a long period of time. Now, think about that scenario. HSBC partnered with Bank of America. Let's say tomorrow they want to get Bank of China invited. Let's say Bank of America wants Bank of China to be invited to the ledger. What are the governance models for new partners to join the network? And so this really becomes kind of a key challenge for this organization. The third one is latency and throughput. And it is as much perception as reality, but a lot of people still believe that blockchain can only do 7 transactions per second. Well, we know that a mainframe on a single engine can do easily 2,000 transactions per second. Now, there are intrinsic issues with smart contracts which sometimes will make them problematic in terms of their execution, and we're going to get into that. But latency and throughput tend to be also very key concerns. So what are the kinds of questions that you need to ask yourself? The first one is, especially if you have not started with blockchain, is how do you get started? And it can become a little bit complicated, right? We have kind of done an inventory of a number of kind of blockchain implementations out there. There are 4 or 5 big ones, but there are dozens. There are dozens of vendors who will sell you a blockchain infrastructure with a specific spin on a specific vertical. They will target finance, trade finance. They will target healthcare, supply chain, right? Do you choose that domain-specific network? Do you choose a generic network? So it's very important for your teams to be able to get started very quickly and understand the pros and cons of the different technologies which are out there. The second one is really around security. Ultimately, chances are you're going to run those blockchain networks within your firewall, outside of your firewall, There are a bunch of implications in terms of data security. You need to understand those. Third one is really around kind of a network and performance. Again, latency is your enemy on those networks, and so you need to actually really consider that. And the last bit is that, especially for a lot of the implementations we see in this earlier phase of the adoption, these are new applications. These blockchain networks are really additive. They are not replacing existing systems. And so chances are, so if I go back to my example of Bank of America and their line of credit, at the end of the day, that stuff has to integrate with their systems of record, right? And those systems of record, especially in finance, healthcare, guess what? They run on mainframes. And so the integration between those blockchain networks and your system of record is a key consideration. So let me start with kind of what are we doing in that space. So the first kind of area which seems mundane is, in working with a lot of our mainframe customers, we're trying to experiment with HyperLedger, which is an open source project. So CA is a member of HyperLedger. HyperLedger was originally donated by IBM. There's a number of companies, both vendors, large enterprises which have joined HyperLedger. So we are actively engaged in the HyperLedger project, and we've built some tooling to help you get started very quickly. So if you are trying to run a hackathon, for instance, internally, to literally kick the tires or experiment, we have tooling to let you literally deploy to dozens, hundreds of developers, a very easy command line tool, which is demoed, I think, over there, that's called Brightside, that really enables you to get started very quickly and automate the entire process for a developer to go from nothing on their desktop to have a sandbox running on the mainframe with MongoDB, HyperLedger, everything they need to get started. The second key area we've been investing is really around security and data security and compliance. So back to kind of a paradox, right? In many ways, the blockchains have been created, or one of the key values of a blockchain is really around transparency of the data. Everybody has access to the data. But really, is this really the real value? The real value is that everybody has a copy of the data so that nobody is controlling that data. But it doesn't really, blockchain doesn't really prereq for everybody to have full visibility onto everything on the blockchain. And HyperLedger has several mechanisms, such as channels and others, to actually partition who has access to what. So that's kind of the first key capability. But the second key capability is, do you understand what kind of data is on the ledger? Do you understand, if you have regulated data, who has access to that regulated data? And so we've been kind of evolving data content discovery, one of our solutions, to be able to scan a ledger and discover for you what kind of data is there, is it regulated, who has access to the data, is the access to the data kind of conforming to a typical usage pattern or not? Next, rogue contracts. So what are these things? So all the transactions which are executing on a blockchain are executed through what's called a smart contract. That smart contract basically is executing some specific business rule to validate that that transaction is valid. It might be to reach out to a partner to validate that there's enough inventory. You can imagine all sorts of business rules that piece of code is executing. Now, one of the challenges is when these smart contracts get rogue. So what we mean by rogue is that oftentimes you will get a piece of code that is non-deterministic. And let me tell you, HyperLedger doesn't like that. It will basically start to re-execute those smart contracts, and you will get into a world of trouble. And so what we've been doing is using mainframe operation intelligence as a core technology to basically monitor what's happening on the network and be able to identify very early that you have one of these smart contracts, which is really a transaction that's trying to be executed, that is not completing for one reason or another. And so we are applying machine learning to basically the feeds of transactions on the network to detect those rogue smart contracts. The last area we've been working on is what we call kind of a shadow blockchain. Again, in many ways, a lot of the early implementations of blockchain are going to be extensions of your systems of record. And so the blockchain applications are going to be integrated with your systems of record. Now, there's even a step before that. And I'll use, for instance, one of the examples from IBM Global Services. One of the first public implementations of blockchain in production from IBM was actually IBM putting on a blockchain all the transactions from all their suppliers worldwide. Right, so they would get basically bills in their SAP systems. They would take that and dump that in a ledger. What's the value? Well, the value is that now all the suppliers and IBM have one source of truth that they share. All the suppliers can see exactly what's been happening. And when there's a dispute, everybody can go to that single source of truth that's encrypted, that's shared, to actually resolve the problem. And they literally went from weeks to resolve a dispute with a supplier to literally hours or days. And so, one of the first steps that we typically see is really around just mirroring transactions with your supply chain to start to provide that kind of value around visibility. And once you have that visibility established, that trust established, then you start to create value on top of that. You start to really create apps with true transactions. And so we've been kind of providing an easy way for you to start to mirror transactions which are happening on DB2, IDMS, or Datacom on HyperLedger. So if I summarize kind of the four areas CA is investing in, the first one is really around enabling developers to get started quickly. We want developers to be able to kick the tires, to not have to deal with complexities of a mainframe, to start to have a sandbox and experiment with blockchain. Second one is around security. We see security as kind of a key concern for many customers. They need to understand what type of data is on the ledger, who has access to that data. The third one is really around this notion of rogue contracts. And how do you ensure that the network is healthy? And the last one is really around the ability to quickly automate the creation of transactions in the ledger. Now, we've been engaging with a number of customers, really across all industries, right? It's really ranged. I would say that finance, retail are probably the most advanced. But across other industries, we've been engaging with customers. And really, we are trying to partner with these customers to understand what are the roadblocks, what are the challenges that they see as they start to adopt or implement blockchain applications. So we're happy to engage with you if you are trying to run a hackathon and put in place the tools for you to run that. We're happy for us to engage with you on what we've learned in terms of what works, doesn't work, in terms of kind of first steps. And really our goal is to learn with you and evolve our solutions to be able to serve your needs. So in terms of content at the conference, just after this session, we have actually a speaker who actually really knows something about blockchain. I'm just, a product management guy, who is really going to get much deeper into blockchain. And really most of the action, if you want to see what we've been building around blockchain, is in the smart bar that's located over there, where we have demos of both data content discovery, mainframe operation intelligence, Brightside, to show you what we've been doing with blockchain and specifically HyperLedger. I'll just say that we've been very focused on HyperLedger first. The reason being that we are on the mainframe. IBM obviously is promoting HyperLedger and their commercial version of HyperLedger on the mainframe. But we're looking at other blockchain implementations. So we don't anticipate, we believe that there is a much broader opportunity for us to apply the same kind of technology and solutions beyond HyperLedger. So with that, thank you for attending the presentation. Candidly, I was not expecting to have such a big crowd. So thank you all for coming. And we will be at the Smart Bar If you have any questions, you want to see demos, we'll be happy to show you what we have. And if you have any further questions, feel free to come see me. Thank you.